So let's see the chemical bonding. As I told you, I'll start from very basics. So let's pull out the concepts from very scratch. So we know that all the matter, it is consists of different elements. Yes or no? For suppose you take anything, you take a table, you take a anything, wood, whatever our body, it's all just made up of different elements. Yes or no? We further classify those elements into organic, inorganic. So just remember, under normal conditions, group of atoms found to exist together. Okay. So what do we call when they exist together and they exhibit certain characteristic properties? What do we call?
So molecules, sir.
Compound.
Yeah. So first it will molecule and later it will form into a compounds. So remember, under normal conditions, a group of atoms is found to exist together as one species. That means except noble gases, because they are very stable enough so they can remain isolated. They will not want to collab with someone else. They don't want to exist with someone else. Okay. And they will show certain characteristic properties. Those are known as the molecules. And remember, in different states of matter, the value of forces between the atoms vary. So can you tell me what does that mean? Can you explain what does this mean?
Is it like solid, liquid, gas? How they packed?
Okay, yeah. Okay, so the different states of matter, the values of forces between them, between the atoms vary. Okay, for suppose, tell me how does the force between the gases and the solids present?
Solid, it's very tightly packed, whereas gas is it is spread
So
about.
why does they tightly pack it? I'm asking about the force, the value of forces. For suppose if you take the gaseous, so these gaseous are loosely packed, right? And you take about the solid, how they are packed? They are packed very tightly. Okay, so what's the reason being the gaseous are packed very loosely and the solid packed very tightly? For suppose if you take the gaseous, the force of attraction between the two atoms, it's very less. It's very minimum. Okay, so what I told you here, so the atoms they come close to each other. Okay, due to the force of attraction, that's the value of the forces, and they will make a molecule. Okay, if you take the atoms in the gas, the distance between them is less. I mean, the distance between them is more because the force of attraction between them is less. And you take the solid, the distance between them is less because the force of attraction is more. So here, the atoms, due to the force of attraction, they were very close to each other. Whereas in gaseous, the force of attraction is not that much great. So they are very distantly packed. So this makes them very spaciously present. This makes them very closely packed. Understood?
Yes, sir.
So
Yes,
as
sir.
these are very closely packed, that's the reason why we cannot pass through a solid. Can you pass through a wall? That's the reason why the question comes. Why don't we pass through a wall, which is a solid, but we can pass through a gas or we can pass through a liquid? You understood? For suppose you take a liquid, it was somewhat still there's a distance between them. So that's the reason it will offer resistance. If you want to walk through the water, you will your speed will be decreased. But if you walk through the solid, you cannot walk at all. If you walk through the gas, easily you can do that. You understood? Here they are spaciously present, so you can walk through them. Here somewhat closely packed, so it will offer a little resistance. And here it's completely closely packed, so walking through them is very difficult. You understood this?
Yes.
Yes, sir.
Yes.
See, don't think it's very basic. I'm just trying to make you understand from very minute detail. Okay, so understand this. The gaseous particles, they have a minimum force of attraction. Whereas in solids, they have the highest force of attraction. Is this clear, right?
Yes, sir.
Yes.
Okay. So now there are many questions. Okay. So first of all, so why do some atoms combine while certain others do not? For suppose you take noble gases, they will not combine. Okay. But certain other atoms, they combine. What's the reason for them to combine, for others to not to combine? So why do various atoms constitute a particular molecule? That means they will combine in certain ratios and it will form always that molecule. What's the reason? And why do these molecules have a definite shape? And what is the nature of the force that exists between the atoms combined? Okay, so these are the many questions that will come. So all these questions are given or can be answered if you understand the chemical bonding. Clear?
Yes, sir.
Yes.
So chemical bonding. What is chemical bonding? How do you define chemical bonding? Come on, guys, tell me. How do you define a chemical bonding?
Force acts between two or more atoms that hold together uh, for a stable molecule.
Yeah, that's true. So the attractive force that holds various constituent atoms or ions together in the chemical species, it is known as chemical bonding. Okay, that means you can take an atom, you can take an ion, so they will be held together by the attractive force. Remember, the bond is always formed by the attractive force. It is called as the chemical bonding. Okay, so you should understand here what is the main reason for the formation of a chemical bond. That is the attraction, right? The main reason is it is a attraction. So when I say about this attraction, that will also tells about me the strength of the attraction. If there is a more strength of the attraction, it will form the stronger bonds. If it is a less strength of the attraction, it will form the weak bonds. Yes or no? So the stability of the bond or the stability of a chemical compound, that is given by the attraction. So how much stronger the attraction is present between them. Okay, it will tell us the greater the stability, the greater the bond, the stronger the bond. Is this clear?
Yes.
So this
Yes,
is
sir.
the attraction between constituent atoms. So attraction between the atoms will tells us about the stability. If the stability is more, then we say the bond is very stronger. If the stability is less, it says the bond is weaker. So this will tells us the strength of the chemical bond. So you can see here, the stronger the bonding between the constituents, the more stable the resulting compound will be. So what is this mean? The stronger the bonding. That means the attraction between them is also very strong. Then only it can form the stronger bonding. Okay, so that they cannot be separated. If you want to separate them, you need to put a lot of energy. Is this clear?
Yes.
Yes. So next one. So see here, molecules are compounds made up of two or more atoms that are joined together by some force of attraction between them. Okay, so these forces are termed as chemical bond. So remember, why do the bonds form? That's because of force of attraction. We may say ionic bonds because of positive and negative, they are opposite charges, so they attract each other. Not only in the ionic bond, it can also happens in the coordinate covalent bond. It can also happens in the covalent bond. Okay, so always remember, it's not only the force of attraction present only in ionic bonds, it is present in all the other types of bond, but the amount of force of attraction, it may vary. So understand this. So molecules are compounds made up of two or more atoms that are joined together by some force of attraction between them. So these forces are termed as chemical bonding. Am I recording? I think I paused the recording. Did I resume it?
Yes, sir.
Yes, sir.
So see, a chemical bond is a physical phenomena in chemical substances that are held together by attraction of atoms towards each other. That could form the sharing, that could be form complete transfer electrons, whatever. Okay, so sharing as well as exchanging of electrons. Sharing, it will form the covalent bond or coordination covalent bond. Exchanging of electrons, it is a ionic bond. Clear? So this exchanging of electrons, it will produce the electrostatic forces. That means the charges will be opposite. So we know unlike charges will attract each other. Like charges will repel. So here the electrostatic force will make the bond between the two. These 2 points clear?
Yes.
Yes, sir.
So tell me now, the question is, why does a chemical bond forms? So you said for attaining the stability. How does this happens? So why does an atom cannot stay independently? Instead, it want to combine with the others. So what happens in these two? Atom alone, atom combining with the other. What happens?
So they share electrons, sir,
Why do they share?
for stability.
How does the stability gets?
So,
Yes.
so by filling their valence shells,
Okay. Again. So what makes them? If you fill the valence shells, they will get the stability. What happens if they are not filled?
So is it like they'll be less reactive when there is a molecule?
See, less reactive. They are reacting because they want the stability. So why they are reacting? What is the basic motivational force for them to join in the bonding? So why atom, when it is present alone, it is not stable? Why atom, when it is joined, it becomes stable? What's the reason? You may say octet configuration. You may say the outer shells are fully occupied or half occupied. What makes them, when they are fully occupied, what will be the energy levels, and what will be the energy levels when they are half filled or when they are like not filled completely? Can someone tell about in terms of energy? The energy when it is when an atom present independently, and the energy when atom forms bonding with the other one. Come on, guys, try. So tell me which one will be having more energy, Sharon? Atom or molecule? I mean, if you take the atom, let me show you. So for suppose you take an
molecules are
atom.
more stable than atoms.
I didn't ask about the stability. I'm asking about the energy levels. So this is the atom individual. This is the atom when it is combined. So now tell me what is the energy level of A here and what is the energy level of A in this case? Sharon, quickly answer. If it is right or wrong, just answer it.
Left side yeah,
Where?
energy.
Less here or less here?
A is more, I think.
Here more energy.
Yes.
Okay. Sharon says the energy here is more than this. Okay. What about you, Banu?
So I think atom has more energy, sir.
Okay. What about you, Shikhar?
So same, sir. Independent. It has more.
Okay, then if it is having more energy, then why it is not stable?
So cause it has more energy, it is not stable.
For suppose I just, you know the concept of potential energy, right?
Yes, sir.
For suppose if I
Yes.
keep the rock on the floor, there's no tension at all. But if I keep the rock on your head, when I'm just changing the position, it will gain energy. When it is more energy, it is less stable. Yes or no?
Yes, sir.
For
Yes.
suppose if I just put the rock here on the floor, you will not feel any tension. But if I just put this rock just above you, holding it, what happens? It will create so much tension on you. Yes or no? Why? The potential energy of the rock has increased. So when the potential energy is increased, the stability decreases. That's a universal fact. So see here, it is a universal fact that every system tends to lose the potential energy to attain the stability. If the potential energy is very high, then the stability is very less. If the potential energy is very less, then the stability is maximum. Okay, so both are inversely proportional. So when they undergo bonding, they will reduce the energy of the system so that they will attain the stability. For suppose you take when two atoms approach each other, Okay, so these two atoms, they have more potential energy, but when they combine, they loses this energy, so the energy levels decreases in them, so they become stabilized. So decrease in the potential energy of the system when they combine, so they will be exist like a stable ones. So whenever you have a octet configuration, the energy becomes very less. But when you have a incomplete configuration, the energy will be very max. So it will make the species reactive. So they will undergo reaction, okay, because of more energy. Okay, but when they fully occupied, the energy levels in the system, it will be very less. They will calm down. They will not react. So the decrease in the potential energy leads to decrease in the total energy of the system, and the energy that is released is known as bond energy. Clear? So again, here when they combine, the energy is released. Yes or no? So that we call it as bond energy. The same way, if you want to break down the bonds between the two, so you need to supply energy equal to the amount of energy that, okay, that is exist between them. You understood? So if I want to break down this molecule, I need to provide the energy equal to the bond energy. Then only they will break down each other. Is this clear?
Yes.
So atoms combine and they liberate certain energy. The same way, if you provide that much energy, the atoms will break down and forms the individual atoms. The molecule will break down and form the individual atoms. So understand this. Have to provide energy equal to bond energy to break the bond. Next one. So when two atoms approach each other, the force of attraction and repulsion between them come into play. Okay. So tell me, what are the force of attractions and repulsions you will be seeing in the atoms, in the two atoms? Come on, quickly. So what happens between the nucleus and electrons? Sharon, tell me what happens between the nucleus and the electrons? The force of attraction between the nucleus and the electrons. Is it attraction or repulsion?
Attracts.
What happens between the two nuclei, Banu?
So they reduce off.
And Shrikar, what happens between the electrons?
So the repulsion.
Yeah. So here we'll be seeing, so when the two atoms approach each other, the force of attraction and repulsion between them we'll see. So first one is the attraction between the nuclei and the electrons. We know electrons are negatively charged, nuclei are the positively charged. Okay. So as they both are opposite charges, it will be favorable for them to attract because they are opposite charges. So attractive forces, I mean, the attraction force will be favorable here, so that they will come and they will be together. Clear? So electrons all will be attracted to the nucleus and lower their energy. And that's how they will form the bonds. But there will be repulsions between the two nuclei. So both are same charges and same charges will oppose. The same goes with the electrons. So when the atoms come closer, the electrons repel each other. Okay, because of having the same charge. So this will increase the energy levels. So this will increase the energy in the system. This will increase the energy in the system. This will decrease the energy in the system. So if this one alone, if it is greater than this and this, then it will lead to bond formation. If this one is lesser than this and this, then the bond formation will not happen between the two atoms. You understood? So when the atom A and B coming close to each other, there are three forces will be exhibited. One is the force of whatever the nucleus is there, this nucleus on these outer electrons, on these electrons and on the outer electrons, so that the energy in the system will decrease. But whatever this nucleus and whatever this nucleus is there, both are positive charges, so they will show certain repulsive forces. And whatever the electrons that are present here and whatever the electron it is present here, they will show certain forces, opposing forces. So these two opposing forces If it is lesser than the force of attraction between this nucleus and this electron, and between this nucleus and the electrons here, then the bond formation will happen. If these opposition forces, if the repulsion forces is maximum, then the force of attraction, then the bond will not form between the two atoms. That's why when the bond formation happens, it will only happen in between certain atoms in a particular proposition. This is the reason. You understood?
Yes, sir.
So you can see here. You can see here. So this is the graph where you can see this is the potential energy level. So this is the zero potential energy. This will be the positive. You can take here the positive values. The potential energy increases and the potential energy decreases. So this is the minimum potential energy. You can take the lower side is the minimum potential energy and this is the maximum. So maximum PE, minimum PE. So we know the stability comes when it is here. Don't think that potential energy is zero, the stability is maximum here. Okay, I mean the stability maximum here. No, you can take the potential energy to minus levels also so that the stability can be much more stronger than this position. You understood this thing?
Yes, sir.
Yes.
Okay.
Yes, sir.
So now see here different internuclear distances. That means the nucleus and nucleus distance. So if you increase the distance between them, the potential energy has increased. For suppose you see here the radius, it is 300. The distance between from this nucleus to this nucleus, the internuclear distance, it is 300. So the potential energy is increased. But the atom trying to come closer, so it was decreased. So this is the intermediate separation. This is the completely dissociated. Okay, this is complete dissociated or completely different, far from each other. So dissociated, and this is somewhat intermediate separation you can take because they are separated with less distance. And you see here, this is a bonded state where the more stability configuration you can see. The distance is r is equals to 74, the radius, and the potential energy is very minimum. So if the potential energy is very minimum, then the stability is maximum. So these atoms can combine with each other. Okay. So that's the reason why they don't want to be present independently. They want to be present in the H2 state. For suppose you take hydrogen gas in the atmosphere, you will find this compared to this. The reason being, so when they are separate, when they are dissociated, the energy here is maximum, they are very less stable. So they want to react with each other. So as they react, the energy will be decreases, the stability attains. Clear? So understand that the negative potential energy here, in this case, it will indicate the atom is more stabler. So hydrogen is more stabler compared to the hydrogen molecule is more stabler compared to the hydrogen atom. And you can see here the force of attraction. For suppose here, this is the nucleus of the hydrogen, this is the nucleus of hydrogen. So both will oppose with each other, but these two will attract. If you take this is the hydrogen, hydrogen will be having one electron, so you can take EA. Okay, and you can take this is a nucleus. So this nucleus, the force of attraction on this electron, it will show the force of attraction. And this nucleus on this electron, it will show the force of attraction. And this nucleus on this electron, it will show the force of attraction. And this nucleus on this electron, it will show the force of attraction. The opposite charges will attract. So that's the reason why it will want to combine. But if you see here, this positive charge and this positive charge, it will oppose the combining. Okay, it will oppose the bond formation because both are same charges, so they will oppose. They will show the repulsive forces. So the solid line indicates that it is a repulsive force. So this is a repulsive force. And you can see here, this is the attractive force. The dotted line indicates the attractive force. So if you see here, the repulsive force is this, and this one, this electron and this electron also shows the repulsive forces. So there are two repulsive forces, but four attraction forces. Okay, that's happening between the two nuclei and the two electrons. In this case, the attractive force between the electron and the nuclei, it will overcome the repulsive forces present between the positive and negative and negative. So that is reason being the atoms combine. Is this clear?
Yes.
Yes.
So attractive force between electron and nuclei overcome the repulsive forces between, you can take the positive and positive or negative and negative. So you can say the repulsive forces between the like charges. So that will result in formation of the stabilized bond. So that's the reason why you can see here the potential energy is very less compared to here. You understood? Please try to understand the concept. Chemical bonding is not the subject, it's not the concept where you by heart. It's a concept where you have to understand. And this is a very basic for all the chapters. Anyways, you are doing this at the end of the 12th. That's okay, fine. So see here, so when two atoms of hydrogen are present far from each other, the potential energy is nearly zero. Okay, and when they combine, there is no such force of interaction between them. Okay, so respect to each other because there is no such force of interaction between them. For suppose you take here, so this hydrogen and this hydrogen, when they present far from each other, there is no force of attraction. So in this case, the potential energy is zero. Okay, but when they move towards each other, so the distance, when it is reducing along the force field, the potential energy decreases and it reaches the minimal value. When still it further reduces, so there is no potential energy, or you can say the potential energy is much more reduced. And that is very, very helpful for the atoms to present in this state than this state. So atoms doesn't want to be here. Atoms want to be here. That's the reason why they will form the bond and they will exist in this state compared to this. Because here they have a less energy. So they have a more stable. Whereas here they have more energy. So they are very less stable. So if the atoms move further closer, then the repulsion between the two nuclei increases. So you can see here, yeah, I forgot to tell this. For suppose if you see here, the force of the potential energy was decreasing, decreasing, decreasing. And here the bond is formed when the potential energy went to the minimest value. You can see the minus 435. But then if you still go, I mean, if still the radius try to decrease, let's say the radius become R is equals to, let's say the radius, if it want to go less than 74, let's say it is 60, then what happened to the potential energy? It was very rapidly increased. You see here, it was suddenly started increasing and it went more than zero. When they are present in isolated state, still it is less than zero. But when they form, when they become very close, it went to too much high, sudden rapid hike. This is the reason. Okay, so if the atoms move further closer, what happens? So there is a nucleus, there is a nucleus. So these nucleus now become very closer and they oppose very strong repulsion forces. Okay, so there is a strong repulsions between the two nuclei. So that leads to the rapid increase in the potential energy. Is this clear?
Yes, sir. Yes, sir.
Yes, sir.
So now tell me, what is the answer for this? What is the answer? Are still you are taking time for this to answer?
Energy is released, sir.
What about you, Sharan Swikar?
Energy is released.
Swikar,
Yes, sir.
you're ఏం చేస్తున్నారా?
Nothing, sir. I feel like.
పడుకున్నావరా నువ్వు?
No, sir.
So the answer is A. So when the atoms combine to form a molecule, I told you certain amount of potential energy will be released and it will make the atom to have a lesser potential energy in the system. That will bring them the more stability. So here the energy is released so that they will combine and form the molecule. Okay. So let's see what are the different types of chemical bonds are there. So first one, the electropositive and electronegative atoms, they will combine together and form a bond, which is ionic bond. Okay. Two electronegative atoms, they will combine, then it will form the covalent bond. Two electropositive atoms, they will combine, then it will form the metallic bond. So we'll see each of these bonds. So understand that if it is positive and negative, then it is a ionic bond. If it is both are negative, then it is a covalent bond. If it is a positive and positive, then it's a metallic bond. Is this clear? So notice this. If they are having opposite charges, ionic bond. If they are having two negative charges, covalent bond. If they are positive charges, then it's a metallic bond. Any doubt in this? I'll explain you in
Yes, sir.
detail. So what is this ionic bond? What is this covalent bond? What is this metallic bond? So let's see ionic bond. So the chemical bond formed between two or more atoms as a result of complete transfer of one or more electrons from electropositive to electronegative atom. Okay, I'll explain with the example. For now, you just understand this. For suppose you take a sodium, you take a chlorine. So this sodium, what happens? It is 2, 8, 1. Okay, and here the chlorine, it is 2, 8, 7. Okay, here the sodium is having the extra electron, which is making them to have more potential energy. And here there is an incomplete electron. There is a requirement of one electron so that the outer orbitals will be completely filled. So this is also having more potential energy. So what happens? Both will come closer to each other, and whatever this electron is there, the sodium will donate to the chlorine. So when it donates, what happens now? The sodium will become 2, 8. So all the outer shell electrons are completely filled. So it lost the potential energy. Now it become more stable. And you see here, now this will become 2, 8, 8 after receiving one electron from the sodium. So here the chlorine also got the complete configuration in the outermost shell. So it will decrease its potential energy. It will become more stable. So one lose the electron, so it will gain positive charge. One gain the electron, it will achieve the negative charge. So positive charge and negative charge, Na plus Cl minus, come closure and will form NaCl. So that's a ionic bond. Why they gain the positive charge? Why they gain the negative charge? We know that number of electrons and number of protons in a normal state, in a normal state, in a ground state, it is equal. So the sodium is having 11 electrons and 11 protons. And the chlorine is also having 17 electrons and 17 protons. But now what happened after donating one electron? Now it gained the 10 electrons and 11 positive charge. So the difference here is 0, but the difference here is +1 charge. So that's the reason why Na +1 after donating one electron. If it donates 2 electrons, +2. If it donates 3 electrons, +3. So you can take calcium +2. Okay. The same goes with the chlorine. It gained one electron, so it become 18 electrons and 17 positive. So here it's a -1. If it is 19 electrons and 17 positive, it is -2. So if it gain one electron, it's a -1 charge. If it gains 2 electrons, it is -2 charge. Oxygen gains 2 electrons, so O -2. Clear?
Yes, sir.
So why the opposite charges built between them? Electropositive and electronegative. So the bond formed as a result of electrostatic attraction. So one being the positive charge, the other being the negative charges. So both are unlike charges, so they will attract. So that we call it as electrostatic attraction between the positive and negative ions. So they will form the electrovalent bond or ionic bond. Remember, ionic bond is also called as electrovalent bond. Don't confuse. It is called as electrovalent bond because it got the bond formation because of electrostatic attraction or the opposite charges. Sharon and Shrikar, is this clear for you?
Yes, sir.
Yes, sir.
Okay, so next one, see here. So electropositive atoms have tendency to lose electron and forms cation. So cation is a positive charge, remember. And electronegative atom gain electrons and it will form the anion. Anion is a negative charge, remember this. Okay, so cations are positively charged, anions are negatively charged. So they opposite to each other, so they have a tendency to attract to each other and they will form ionic or electrovalent bond. Okay, so compounds containing ionic bond are called as ionic compounds or electrovalent compounds. Remember this. Okay, so in ionic compounds, each cation is surrounded by the negative ion, or each negative ion, it is surrounded by the cation. So remember this. If it is negative, it will be surrounded with the positive, or if it is positive, it will be surrounded with the negative. Understand this thing. So number of ions immediately surrounding the central ion is known as coordination number. So we saw this. What is coordination number? In the coordination compound, the number of ligands surrounded around the central metal atom. The same way here also, the number of ions that are surrounded around the central metal atom, we call it as coordination number. Clear? For suppose you
Yes.
take the carbon, carbon, and chlorine, chlorine, chlorine. So around this carbon, the 4 were surrounded. So like that. Okay. Here chlorine is negatively charged, here negatively charged, carbon being the positively charged. So that's how. So you can see here the examples. The sodium, when it loses one electron, it will become positive. The chlorine, when it gains this electron that is from the sodium, it will gain the negative charge. So both are opposite charges, so result in formation of ionic bond. Is this clear? What is ionic bond without any doubts?
Yes, sir.
Yes, sir.
No
Yes,
doubts,
sir.
right? Okay, so next one. So covalent bond. Here, the chemical bond is formed by sharing of one or more electrons. Okay, between the two electronegative atoms, when each atom contributes equally, is known as covalent bond. Okay, in simple words, if I say, so you have a red pen, I have a black pen. Okay, so let's say, yeah, you have a blue pen, I have a black pen. So we want to write the notes, but we should use both we should use both black and blue. Okay, so what I do when I write with the blue pen, I'll write it, but when I want black pen, I'll give you the blue pen and I'll take the black pen. The same with the B. So when I write with the blue pen, I'll write with this. When I want black, I'll take. That means here both are equally contributing and both are sharing with each other. So that is a covalent bond. Here, a chemical bond formed by sharing of one or more electrons. So here A is sharing the electrons, B is sharing the electrons, and equal in number. That is very, very important. Okay, here both are contributors. That is how the covalent bond is differentiated from dating bond or coordination covalent bond. Okay, so remember here both A and B, they both are contributors. They are contributing the electrons, and they are contributing the electrons in equal level. For suppose A is giving one electron, B is giving one electron. A is giving two, B is giving two. A is giving three, B is giving three. So they should give equal contribution. Then we call it as covalent bond. If it is not equivalent contribution, then it's not a coordination bond. It's not a covalent bond. The other type bond, which is a coordination covalent. Clear?
Yes, sir.
Yes,
Yes.
sir.
You can take the example here, the hydrogen molecule. So we know hydrogen is having 1s1. So that means one electron is present. Okay, but we know in the in its outermost shell, in the shell, two electrons need to be fitted so that it will gain more stability compared to one electron. And it also gets the stability of the nearest inert gas, which is helium. So what hydrogen will do? It will combine with the other hydrogen. They will come closer. So they will make the bond between them. So by equally contributing, by sharing the electrons. So this is how the formation of a stable covalent bond, which is nearest noble gas, the helium. Okay, so remember, atoms always try to attain the nearest stable inert gases configuration so that they will reach the stability. Here, two hydrogens attained the helium configuration. So helium is 2, that means 1s2. So 2 electrons are filled. This is the only one where you will be seeing the duplet configuration stablest. Remaining all are, you will be seeing the octet configuration stable. Okay, only in the hydrogen and helium cases where the duplet configuration is stable because they are present in the first shell. In the first shell, only s orbital is present. So they just only need 2 electrons. They don't need 8 electrons or more than that. Okay, so remember, only for helium and hydrogen, the duplet configuration is the stablest configuration. But remaining all the other atoms, that octet configuration is the stablest one. Even you can take the lithium also. Lithium also want to donate the electrons so that it will get the nearest helium stablest configuration. Okay, so let's talk about that later. Is this clear for now?
Yes, sir.
Yes, sir.
Yes, sir.
So based on how many pair of electrons are sharing, they are classified into 3 types. One is the single covalent bond. That means only one bond is present between them, which involves pair of 2 electrons. Which involves pair of electrons. That's a 2 electrons. Double covalent bond. That means double bond, which involves 2 pair of electrons, or total 4 electrons involved, or triple configuration. Triple bond, triple covalent bond, which involves total 3 pairs of electrons. So if it is 3 bonds, we call it as triple covalent bond. If it's 2 bonds, we saw in organic chemistry, there's a single bond, double bond, and triple bond. between the alkanes and alkynes. Okay, so let's see what is a single covalent bond. When one electron pair is shared between two atoms, each atom contributes one electron. They are said to be connected by single covalent bond. Remember, in single covalent bond, between the two atoms, one pair of electron will be involved. In that one pair, one electron will be given by one atom, the other electron will be given by other atom. And both the electrons will be shared equally by the A and B. So here, A will share this and B will share this. Clear? Okay. So remember, when one electron pair is shared between two atoms, each of atom contribute one electron. They are said to be single covalent bond. Can you tell me example for single covalent bond? You know chlorine? How does the chlorine forms? So tell me, what is the outermost configuration of this chlorine? Come on, guys. What is the atomic number of chlorine? Tell me at least this.
17.
So it's a 17. So if I
So
write
it
in the configuration, it will be 1s2, 2s2, 2p6, 3s2, 3p5. Yes or no?
Yes,
Or you
sir.
can write like this. So 1s2, 2s2, 2p6, which is nothing but the neon configuration, which is 10. And then you have a 3s2, 3p5. Yes or no? So if you
Yes.
see this outermost shell, it is having the 3s. If you see this outermost shell, the 3s and 3p5. So this is 3s2 and this is 3px, 3py, 3pz. Okay, so see here, one electron is needed. So if you get the one electron, now it will become, if you see here, the outermost configuration here is 2 plus 5, which is 7. But in order to make the 8, you need to put one electron here. Okay, so if you put one electron here, then it will become 8. Okay, is this clear?
Yes.
Yes, sir.
So how does it will gain that one electron? So it will take from the other chlorine. You take this chlorine. So if you see this chlorine, it is having total 7 electrons. So let's say 1, 2, 3, 4, 5, 6, and there is a 7. You take another chlorine, but it is having, it is also having 7 electrons. So you see here 1, 2, 3, 4, 5, 6, 7. So they will come together and they will make the bond between them. So now see here, how many are there? So 1, 2, 3, 4, 5, 6, 7, 8. So it got full configuration. The same with here. So 1, 2, 3, 4, 5, 6, 7, 8. So here one chlorine and other chlorine will make the bond between them. So that bond is a single covalent bond. Single covalent bond involves one pair of electron. You can see here, there's a one pair of electron between them. Is this clear? So how does
Yes,
the single covalent bond is formed? No doubt, right?
Yes.
yes.
Next one, double covalent bond. So when two electron pairs are shared between the two atoms, each atom contributes 2 electrons. They are said to be double covalent bond. Same, you can take here. What is the best example for this? What is the best example? Oxygen. So what's the configuration of oxygen molecule? What's the atomic number of oxygen?
8, sir.
It is 8. That is
2 and
1s2, 2s2, 2p4. Again, you can see here. If you see here, the outermost configuration, so here 2 electrons, here, 4 electrons. But still, it is lacking 2 shells. So it has to be filled and filled here. So if you see here, the outermost configuration, in this case, it is 6. Okay. Outermost configuration containing the number of electrons is 6. But the outermost electron configuration, if it is 8, then it will be stabler. So it requires 2 blue electrons. Okay. So that can be gained, that can be shared with the other oxygen atom, which is also looking for the 2. Is that clear? For suppose if you see here, this yellow will be given by one oxygen atom, this blue will be shared by the other oxygen atom. Okay, so it will be like this. So these 2 electrons, this oxygen will contribute. These 2 electrons, this oxygen will contribute. So both will share, and each of them will get like this. Understood? By sharing the electrons between them. So you can write like this. So oxygen, oxygen. So here this oxygen. One second, guys. Sorry, here if you see here, there are 2 lone pair of electrons, this one and this one, yes or no? So I'll just put them first, and let me put on this also. So let me give this one. These are the 2 lone pair of electrons. So 1 2 3 4. Now these 2 are there, those 2 I'll put here. Okay, understood this? The same I'll put here. There is a 2 lone pair of electrons, and here there is a other 2. So now what happens? They will try to form the bond like this. So now count 1 2 3 4 5 6 7 8. It got the octet configuration. The same way here. So 1 2 3 4 5 6 7 8. So that means there is a oxygen is having 2 bond pair of electrons and 2 lone pair of electrons. Is this clear? So what is meaning of lone pair of electrons? Those which usually not involve in the bond formation, or they will not involve in the bond forming, or they will not involve in the chemical reaction. So those are called as the bond pair. Here oxygen is having 2 lone pair of electrons, and those electrons which involve in the bonding, and those electrons which will not involve in the bonding. So those which will not involve in the bonding, we call them as lone pair. Those which will involve in the bonding, we call it as bond pair. Is this clear?
Yes, sir.
So you can see oxygen is having 2 lone pair of electrons. If you don't know what is lone pair, just understand now itself. Okay, so those which will not involve bonding, for suppose this shell and this shell containing pair of electrons, but still they will not involve in the bonding. Which will involve? Only these 2 will involve. So these 2 are said to be lone pair of electrons. That's why oxygen, we say 2 lone pair of electrons. Clear? So here the bond is formed by 2 pair of electrons. So 2 bonds are formed. So it's called as double covalent bond. Any doubts?
No, sir.
No, sir.
Okay, next one is triple covalent bond. So when 3 electron pairs are shared between the 2 atoms, each atom contributes 3 electrons. They're said to be triple bond. So we know the example. What is the example?
Nitrogen.
Nitrogen. Okay, so what's the configuration of nitrogen? Again,
7. So 2 6
so
2 5.
nitrogen is 7. So you can write it like 1s2, 2s2, or 2p3, right? So 4 plus 3, 7. So if you take this, is you can write like this as well: helium, 2s2, 2p3. So if you see here again, okay, so nitrogen is okay, it's still stable because it's a half filled, but it will attain much more stability when it is fully filled. Okay, half stable is okay, fine, but it will attain the complete stability when it gains the fully filled. So here three electrons are needed for the nitrogen. Okay, so what the nitrogen will do? Now tell me how many lone pair of electrons are present in the nitrogen?
1.
3, sir.
Yeah, Sharan, how many?
3, sir.
Super, Sharan. Banu, what about you?
So yes, दोनों sir.
You
So it's
understood?
one side.
Banu, honestly tell me, have you understood the previous slide?
Sir, yes sir, double. I understood sir.
What is I told you here, what is lone pair means?
So long time they don't usually involve in reactions, sir.
What is meaning of lone pair?
No, not meaning, sir. I'm just a thing.
Yeah, so how
They
many are
don't.
there?
So here,
Yeah. How many lone pairs are present here?
6, sir.
Banu, Banu, what is lone pair of electrons means? What is lone pair of, what is lone pair? LP. Lone pair ante enti? Chebanu, lone pair ante enti?
The unpaired electrons, sir.
No. నేను ఇందాక ఏం చెప్పాను ఏవైతే ఎలక్ట్రాన్స్ ఓకే సో వాట్ ఆర్ దోస్ ఎలక్ట్రాన్స్ విచ్ ఇన్వాల్వ్ ఇన్ ద బాండింగ్ వీ కాల్ ఇట్ యాజ్ బాండ్ పేర్ ఆఫ్ ఎలక్ట్రాన్స్ సో యూ కెన్ సే దీస్ ఆర్ బాండ్ పేర్ ఆఫ్ ఎలక్ట్రాన్స్ okay this electron is involved in the bonding so we call it as the bond pair involved in bonding so electron pair which involve in the bonding and what is lone pair of electrons those electrons which will not involve in the bonding we call it as the lone pair of electrons for suppose you see here is it involving in the bond
No,
This
sir.
one. Is it involving in the bond
No, sir.
so for this nitrogen how many lone pairs are present
4.
Banu pair అంటే ఏంటి ఇప్పుడు నీ దగ్గర చెప్పులు 2
Sir,
pairs అని
two,
అంటావా
two,
లేకపోతే 4 pairs ఉన్నాయని చెప్తావా
two pairs.
Okay, so here how many lone pairs are present 2 lone pairs here how many lone pairs are present 2 lone pairs for
Two.
this nitrogen you should not combine this and this I'm asking about individual nitrogen atom so there's a 2 lone pairs here there's a 2 lone pairs here you understood so what is meaning of lone
Yes,
pair define what is meaning of lone pair of electrons
which do not involve in bonding, sir.
yeah so pair of valency electrons valence electrons means the electrons in the outermost shell not involved in the bonding. See, usually they will not involve in the bonding, but there will be certain times where they has to involve in the bonding. Okay, so understand that when there will be certain conditions where they have to involve in bonding. At that time, you will not call them as the lone pairs. You will call them as bond pairs. But usually they will not involve in the bonding. So they are called as the lone pairs. Okay, so if you see the nitrogen, yeah. So 1, 2, 3, 4, 5, 6.
This is oxygen, sir.
Sorry, yeah. So yeah, you see here. So how many valence electrons are present in the nitrogen? Tell me, in the outermost shell. How many valence electrons are present in the nitrogen?
So 3, sir.
Valency electrons అన్నా valency electron pairs అనలేదు అండ్ పేర్ అయినా సరే 3 ఎలా అవుతుంది ఇక్కడ valency అంటే outermost shell బాను ఫర్ సపోజ్ ఇది ఫస్ట్ షెల్ దిస్ ఈస్ ద సెకండ్ షెల్ then I need to come from the atomic structure not even the chemical bonding understood this is the first shell this is the second shell in this second shell how many electrons are present the valence electrons
So 4, sir.
తీసుకెళ్ళి ఎల్కేజీలో పడాలి నేను valency electrons that means number of electrons in outermost shell
So 5, 8.
so this is the outermost shell the 2s and 2p this is the inner shell 1s 2 so count how many 2 plus 3 it's not 4 2 plus 3 is 5 So Banu, tell me how many valence electrons present in this case?
6, sir.
Yeah. Now understood what is meaning of valence
Yeah.
electrons?
Yes, sir.
So in this valency electrons, those which involve in the bonding, they are called as the bond pair of electrons. Okay. For suppose if you see here, this one will involve in the bonding, yes or no? This one will involve in the bonding, yes or no?
Yes.
So these are the bond pair of electrons. You can see here after formation of the oxygen molecule. But if you see this one and this one, here this one is and this one. So this oxygen is having one lone pair which will not involve bonding. This oxygen is having one lone pair which will not involve in bonding. The same way, this oxygen is having one lone pair, this one is having one lone pair. Is this clear?
Yes, sir.
Yes.
So if I say how many lone pairs are present in this oxygen, how many are present for this oxygen?
2, sir.
For this oxygen?
2.
Yeah. Now see here, how many, this is the valency. So how many lone pairs are present in this?
So 1, sir.
Yeah. Okay. So this is the one which is lone pair. These all involves in the bonding. Okay. So after bonding, now these are called as the bond pair because they will acquire the electrons by sharing from the other nitrogen. Okay. So these are called to be bond pair, but this one is a lone pair. So nitrogen, you can say it is one lone pair and 3 bond pairs for normal condition. But nitrogen can form certain other bonds where this condition can changes. For suppose if it is NH3, that means one nitrogen, 3 hydrogens will contribute each of the electron. So in this case, the bond pair is 3, lone pair is 1. Okay. For suppose you take a NH4 plus, that means what happened? So whatever this lone pair is there, that will also involve in the bonding. Okay. For suppose there is a proton will come. Proton doesn't have any electrons at all. So what it will do? The nitrogen will share its lone pair with this proton. Yes or no? Proton is having only one electron because its atomic number is 1. That electron is also lost. So that's why it is called as H plus because as it's having only one proton inside. So this proton doesn't have any electrons. Okay, so it's just a positively charged proton. So now what it will do, when it comes closer to the nitrogen, no nitrogen will just give its pair of electron to this hydrogen, whatever the lone pair is there. So that's the reason why NH4, where 4 bond pairs are present, 0 lone pairs are present. You take nitrogen, N2, still same, 3 bond pairs, 1 lone pair. You take NO3 minus, here 4 and 0. You understood? So nitrogen, if it donates its lone pair, then it will become 4 bond pairs and 0 lone pair. But usually nitrogen will involve 3 bond pair and 1 lone pair. Clear? So these
Yes.
conditions are very stable. That's why the nitrogen will be NH3 and N2, but not in NH4 plus state or NO3 minus state. They will convert into some other molecules when they exist because these are okay. For some time they are stable, but not all the time because they are also using their lone pairs. So that will create certain problem for them. So they don't want to be in this state. That's why NH4 plus they exist, but if you provide something, they will just break down and it will turn out to be NH3 plus and H plus. Is this clear?
Yes.
So in this
Yes.
case, how does the nitrogen will do? So one nitrogen. So there is a lone pair of electrons which will not involve, but then there are 3 bond pair of electrons which will involve. So 1, 2, 3. The same goes with the other nitrogen. So lone pair which will not involve in bonding, but then bond pair which there's other pair of electrons which will involve in bonding. So now the bond will form like this. Clear? So that's how they will be having triple bond between them and triple bond. Understood?
Yes.
Any
Yes.
doubts?
No, sir.
So just clear here what is meaning of bond pair, what is meaning of lone pair. Okay, so how does the covalent bond is formed? What is the outermost shell? What is meaning of valence electrons? What in that valence electrons, what is the number of electrons which will involve in the bonding, number of electrons which will not involve in bonding. So this is lone pair, this is bond pair. So these things are clear.
Yes.
So this is the outermost shell, or you can also call this as valency shell. And the electrons present in this shell, they are called as the valence electrons. So in this case, 5 is the valence electron. Clear? In that 5, 1 will be lone pair and 3 will be bond pair. Clear? Banu?
Yes, sir.
Yes, sir.
Okay, then I'll just, time is up. I'll stop here.
Thank you.